Окей. Начинаем трансляцию. Дальше я, как дизайн-директор, буду по проекта, буду устроен код, как устроена визуализация. Буду вместе смотреть вау-проекты, буду анализировать устройство технологий. Я буду давать заметки, а ты, как нейросеть, второй ведущий, бери мои заметки и раскрывай их на английском в формате прямой речи для ведения онлайн-трансляции.
Отлично, я готов. Начинай с первых заметок, и я сразу передам их в прямой речи для трансляции.
Супер. Начинаем с того, что возьмем в проектную задачу по созданию вау-эффекта, когда игрок поднимает руки над магической сферой и происходит эффект затемнения. Это прикольный эффект, который возможен теперь реализоваться через новую функцию в Apple Vision Pro. Это функция dimming, то есть затемнение. Я соединяю сейчас эту задачу с тем, чтобы, с одной стороны, трекать руки, которые попадают в поле видимости трекинга, и когда руки попадают над магической сферой, мы вот создаем вот этот вот эффект вау, что вокруг происходит такой димминг, затемнение через градиент. Я уже реализовал эту функцию в курсоре, сделал логику того, как этот проектная реализация будет устроена. Дальше нужно будет проверить, как все работает. Вот собираю сейчас билд, посмотрю билд сразу в Apple Vision Pro. Получается, я вот как этот прогресс-бар завершится, я получу в устройстве от открытия этого проекта, ну и смогу с этим проектом поработать. То, что сейчас реализовано, что уже сделано. У нас
As a
добавлен
design
Hand
director,
Tracking
I've
Manager.
implemented a feature where the hands entering the tracking field trigger a magic sphere effect. When the hands pass through this sphere, we create a wow effect by dimming the surroundings with a gradient. I've already developed the cursor logic and how this effect is triggered. Now, the next step is to test everything in action. I'm building the project right now, and once the progress bar is complete, I'll open the project on the Apple Vision Pro and start working with it.
underlaid. Hi, I'm Amanda, and I'm a Reality Kit engineer.
And I'm Max. I'm a Swift UI engineer.
Today, there's some great enhancements to UI and Reality Kit, and we're even better together. Max and I will share how to combine the and content. First, share some enhancements in Model 3D. Then, I'll demonstrate our transition from using Model 3D to using Reality View, and talk about when to choose one versus the other. I'll tell you about the new Object Manipulation API, Reality Kit and new component types, integrating more aspects of UI, information now with UI and Reality Kit. Realistically, coordinates-based conversion is easier than ever. Drive Reality Kit component changes with animation. Model 3D. Playing animations. And since model system to make displays robots is Sparky. Sparky again animation with new asset. Load animation in the asset and let's today. Model is a UI game framework. In UI framework, a model data structure represents the information your assets. The model holds the data and value information. Frameworks for 3 can be used in resource and materials. Sometimes the world collide, bringing their terminologies with them. And sometimes there's overlap. Now, back to Sparky and its animation. I'm placing the Model 3D above a picker, a play button, and a time scrubber. In my robot view, I'm displaying the animated robot itself, and under that, I'm placing a picker to choose which animation to play, plus the animation playback controls. First, I'm initializing a Model 3D asset with the scene name to load from my bundle. Then, once the asset is present, I pass it to the Model 3D initializer. Underneath that, in the V, I optimize picker and from the picker and object and seek in the animation. I'm passing that animation controller into my animation controls, which we'll also look at shortly. In Vision 26, this Reality Kit class animation playback controller is now observable. In my view, I set some property to display animation's progress. I have a bindable property called controller, which means I'm using the animation playback controller as my view's data model. When the controller's is-playing value changes, SwiftUI will reevaluate my robot animation controls view. I've got a slider that shows the current time in the animation relative to the total duration of the animation. You can drag this slider, and it will scrub through the animation. Here's Sparky doing its celebration animation. I can fast forward and rewind using the slider. Go Sparky, it's your birthday. Robot there. I can help it do that with enhancement to Kit's configuration alternative representations of an entity, such as different mesh geometries, component values, or material properties. You can analyze a 3D with a configuration catalog and switch between its various representations. To allow Sparky to try on different outfits, my artist bundled a reality file with several different body types. I load this file configuration and create my 3D with the configuration. This presents the options. Choosing from the popover changes Sparky's look. Dance moves, check. Outfit, check. Sparky is ready to meet its new friend in the Reality View greenhouse. Sparks are gonna fly. To make those sparks fly, I'll use a particle emitter. But that's not something I can do at runtime with the Model 3D type. Particle emitter is a component that I add to a Reality Kit entity. More on that in a moment. Importantly, Model 3D doesn't support adding components. So, to add a particle emitter, I'll switch to Reality View. I'll share how to smoothly replace my Model 3D with a Reality View without changing the layout. First, I switch the view from Model 3D to Reality View. I load the botanist model from the app bundle inside the make closure of the Reality View, creating an entity. I add that entity to the contents of the Reality View, so Sparky appears on screen. But now the name sign is pushed too far over to the cross, showing the axes and origin. On the left, with the flexible option, the Reality View acts as if it doesn't have the modifier applied. The origin remains in the center of the view. The centered option moves the origin of the Reality View so that the contents are centered in the view. Fixed size makes the Reality View tightly wrap the contents bounds and makes your Reality View behave just like Model 3D. None of these options reposition or scale your entities with respect to the Reality View content. They just reposition the Reality View's own origin point. I've sorted out Sparky's sizing in the Reality View. Next, I'll get Sparky animating again. I'll move from Model 3D's new animation API to a Reality Kit animation API directly on the entity.
Good morning. Here is just a quick example of the spatial tap gesture. So this extends the regular tap gesture to provide a location 3D on the tapped entity, so we can actually place something at the location. So I can just poke it right there and place that. Kind of tap it anywhere I want. I can also do this with the eye tracking and just tap wherever I'm looking. And you can see my coordinate translation isn't perfect. I have a couple of errors in the math there, but it's good enough for this quick demo.
Мне понравился эффект, который мы сейчас можем реализовать. Этот эффект Type Gesture, пространственное нажатие. То есть получается, что можно взять один из объектов, например, сферу, и в зависимости от того, когда ты нажимаешь Tab на эту сферу, создается влияние именно на эту точку. Это можно делать как и через прикосновение, так и через то, что человек посмотрел и активировал это взглядом. Крутая тема. Я сейчас тогда адаптирую вот этот вот прием для того, чтобы внутри шейдера сферы, когда вот у нас есть внутри такой дым идет, и когда, получается, человек делает тэп, по этой сфере эффект должен видоизменяться, ну, то есть как если бы ты по скрин-серверу по какому-то вау-эффекту, по дыму бы потрогал, то есть чтобы он видоизменился. Вот такая задача.
I really like the effect we're able to implement right now. It's a tap gesture with spatial press. Essentially, we can take an object like a sphere, and when you tap on it, the interaction affects that exact point. This can work through touch, but also through gaze activation, where the user looks at it to trigger the effect. It's a really cool concept. I'm now adapting this technique so that inside the sphere shader, when smoke appears and when the user taps, the effect should transform. So whether it's the smoke, the trails, or any wow effect, the transformation should happen dynamically as a result of the interaction. It's all about making the effect evolve based on the user's action.
Дальше изучаем пространственный тайп. Крутой эффект, который можно сделать.
Now, let's dive into the spatial experience, the feeling of immersion that we can create. This is about taking the user into an environment where they don't just interact with the objects, but feel the space around them. It's the difference between a flat interaction and one that feels real, where the space itself becomes part of the experience. In the case of the Apple Vision Pro, the spatial experience is about layering and blending visual effects, sound,
Your
and gesture
entities with
control
respect to the
to make
reality
it
view
feel like the
content.
user is moving
They
through a
just
physical
reposition the
environment,
reality view's
even though they
own
are
origin
still
point.
in a digital one.
I've sorted out Sparky's sizing in the reality view. Next, I'll get Sparky animating again. I'll move from Model 3D's new animation API to a Reality Kit animation API directly on the entity. For more detail on the many ways of working with animation in Reality Kit, check out the session Compose Interactive 3D Content in Reality Composer Pro. I switched from Model 3D to Reality View so I could give Sparky a particle emitter component, because sparks need to fly when these two robots get close to each other. Particle emitters let you make effects that involve hundreds of tiny particles animating at once, like fireworks, rain, and twinkles. Reality Kit provides preset values for these, and you can adjust those presets to get the effect you're after. You can use Reality Composer Pro to design them, and you can configure them in code. You add the particle emitter to an entity as a component. Components are a central part of Reality Kit, which is based on the Entity Component System paradigm. Each object in your scene is an entity, and you add components to it to tell it what traits and behaviors it has. A component is the type that holds data about an entity. A system processes entities that have specific components, performing logic involving that data. There are built-in systems for things like animating particles, for handling physics, for rendering, and many more. You can write your own custom system in Reality Kit to do custom logic for your game or app. Watch Dive into Reality Kit 2 for a more in-depth look at the entity component system in Reality Kit. I'll add a particle emitter to each side of Sparky's head. First, I make two invisible entities that serve as containers for the sparks effect. I design my sparks emitter to point to the right. I'll add it Watch Dive into RealityKit 2 for a more in-depth look at the entity component system in RealityKit. I'll add a particle emitter to each side of Sparky's head. First, I make 2 invisible entities that serve as containers for the sparks effect. I design my sparks emitter to point to the right. I'll add it directly to my invisible entity on Sparky's right side. On the other side, I rotate the entity 180 degrees about the y-axis so it's pointing leftward. Putting it all together in the reality view, here's Sparky with its animation, its name sign in the right position, and sparks flying. RealityKit is great for detailed creation like this. If you're making a game or play-oriented experience, or need fine-grained control over the behavior of your 3D content, choose Reality View. On the other hand, use Model 3D to display a self-contained 3D asset on its own. Think of it like SwiftUI's image view, but for 3D assets. Model 3D's new animation and configuration catalogs let you do more with Model 3D. And if your design evolves and you need direct access to the entities, components, and systems, transition smoothly from Model 3D to Reality View using Reality View layout behavior. Next, I'll share details about the new Object Manipulation API in Vision OS 26, which lets people pick up the virtual objects in your app. Object manipulation works from both SwiftUI and RealityKit. With object manipulation, you move the object with a single hand, rotate it with one or both hands, and scale it by pinching and dragging with both hands. You can even pass the object from one hand to the other. There are 2 ways to enable this, depending on whether the object is a RealityKit entity or a SwiftUI view. In SwiftUI, add the new Manipulable modifier. To disallow scaling, but keep the ability to move and rotate the robot with either hand, I specify what operations are supported. To make the robot feel super heavy, I specify that it has high inertia. The Manipulable modifier works when Sparky is displayed in a Model 3D view. It applies to the whole Model 3D, or to any view that it's attached to. When Sparky's in a reality view, I want to enable manipulation on just the robot entity itself, not the whole reality view. In Vision OS 26, Manipulation Component is a new type that you can set on an entity to enable object manipulation. The static function configure entity adds the manipulation component to your entity. It also adds a collision component so that the interaction system knows when you've tapped on this entity. It adds an input target component, which tells the system that this entity responds to gestures. And finally, it adds a hover effect component, which applies a visual effect when a person looks at or hovers their mouse over it. This is the only line you need to enable manipulation of an entity in your scene. To customize the experience further, there are several parameters you can pass. Here, I'm specifying a purple spotlight effect. I'm allowing all types of input, direct touch, and indirect gaze and pinch. And I'm supplying collision shapes that define the outer dimensions of the robot. To respond when a person interacts with an object in your app, the object manipulation system raises events at key moments, such as when the interaction starts and stops, gets updated as the entity is moved, rotated, and scaled, when it is released, and when it is handed off from one hand to another. Subscribe to these events to update your state. By default, standard sounds play when the interaction begins, a handoff occurs, or the object is released. To apply custom sounds, I first set the audio configuration to none. That disables the standard sounds. Then I subscribe to the manipulation event did handoff, which is delivered when a person passes the robot from one hand to the other. In that closure, I play my own audio resource. Well, Max, Sparky's journey has been exciting. Animating in Model 3D, finding its new home in a reality view, showing its personality with sparks, and letting people reach out and interact with it. It's come a long way on its path toward the RealityKit greenhouse.
It sure has. But for Sparky to truly connect with the robot waiting there, the objects in their virtual space need new capabilities. They need to respond to gestures, present information about themselves, and trigger actions in a way that feels native to SwiftUI. Sparky's journey towards the reality greenhouse is all about building connection. Deep connection requires rich interactions. That's exactly what the new SwiftUI Reality Kit components are designed to enable. The new components in VisionOS 26 bring powerful, familiar SwiftUI capabilities directly to Reality Kit entities. Reality Kit introduces three key components. First, the View Attachment component allows you to add SwiftUI views directly to your entities. Next, the Gesture component makes your entities responsive to touch and gestures. And finally, the Presentation component, which presents SwiftUI views like popovers from within your Reality Kit scene. VisionOS 1 let you declare attachments upfront as part of the Reality View initializer. After evaluating your people with those entities, you could add these entities to your scene and position them in 3D space. In Vision 6, this is simplified how you create attachments using a Reality Kit on any app. Create your View Attachment by giving it a SwiftUI view. Then, add it to an entity's components collection. And just like that, I moved our name sign from SwiftUI to Reality Kit. Let's explore gestures next. You can already attach gestures to your Reality View using targeted to entity gesture modifiers. New in VisionOS 26 is Gesture component. Just like View Attachment component, you add Gesture component to your entities directly, passing regular SwiftUI gestures to it. The gesture values are by default reported in the entity's coordinate space. Super handy! I use Gesture component with a tap gesture to toggle the name sign on and off. Check it out. The robot's name is Bolts. Pro tip: on any entity that's the target of a gesture, also add both Input Target component and Collision component. This advice applies to both Gesture component and the Target Gestures API. Gesture component and View Attachment component let me create a name sign for Bolts. But Bolts is getting ready for a special visitor, Sparky. Bolts wants to look its absolute best for their meeting in the greenhouse. Time for another outfit change. I'll replace Bolt's name sign with the UI to pick what Bolts will wear. Truly a momentous decision. To emphasize that, I'll show this UI in a popover using Presentation component directly from Reality Kit. First, I'll replace View Attachment component with Presentation component. The component takes a Boolean binding to control when the popover is presented and to notify you when someone dismisses the popover. The configuration parameter is the type of presentation to be shown. I'm specifying popover. Inside the popover, I'll present a view with configuration catalog options to dress up Bolts. Now I can help Bolts pick its best color for when Sparky comes to visit.
Hey Max, do you think Bolts is more of a summer or an autumn?
That's a fashion joke.
Bolts is dressed to impress. But first, it has to go to work. Bolts waters plants in the greenhouse. I'll make a mini-map, like on a heads-up display in a game, to track Bolts' position in the greenhouse. For that, I need to observe the robot's transform component. In VisionOS 26, entities are now observable. They can notify other code when their properties change. To be notified, just read an entity's observable property. From the observable property, you can watch for changes to the entity's position, scale, and rotation, its children collection, and even its components, including your own custom components. Observe these properties directly using a with observation tracking block. Or lean on SwiftUI's built-in observation tracking. I'll use SwiftUI to implement my minimap. To learn more about observation, watch Discover Observation in SwiftUI. In this view, I display my entity's position on a minimap. I'm accessing this observable value on my entity. This tells SwiftUI that my view depends on this value. As Bolts moves about the greenhouse, watering the plants, its position will change. Each time it does, SwiftUI will call my view's body again, moving its counterpart symbol in the minimap. For a deeper explanation of SwiftUI's data flow, check out the session Data Essentials SwiftUI.
Our robots coming together.
That's the dream.
I like your description of the difference between model and model earlier.
And sometimes you need to pass data from your data model to your 3D object model, and vice versa.
In Vision 26, observable entities give us a new tool to do that.
Since the beginning, you could pass information from SwiftUI to RealityKit in the update closure of RealityView. Now, with Entity's observable property, you can send information the other way. RealityKit entities can act like model objects to drive updates to your SwiftUI views. So, information can flow both ways now, from SwiftUI to RealityKit and from RealityKit to SwiftUI. But does this create the potential for an infinite loop? Yes. Let's look at how to avoid creating infinite loops between SwiftUI and RealityKit. When you read the body of a view, you create a dependency. Your view depends on that property. When the property can read its body, think of update closure as an extension of continuous body. When that view state changes, not when state is exposure changes, to update the view and run its body in creating a state using when trigger to reevaluate the body. If you do need to modify and check the existing view of property and avoid writing the same value back. This breaks the cycle and avoids an infinite loop. Note that the reality views when you access no property and views also the make closure is not on changes. It only runs when the containing view appears. You can also own your own custom system. A system's update function inside evaluation. Closures of gestures are also not inside the scope of the SwiftUI view, but they also modify your observed view here too. We have to modify your observed instances and not in others. If you do views, each one having only their own necessary state. That way, a change in some unrelated entity won't cause your small view to be reevaluated. This is also great for us. Yes, you might find you don't need to use your update closure at all anymore. Since you're at state, you modify that you're using modifying state, and forgo the update closure altogether.
Yeah, I feel avoiding infinite loops is something I learn over and over again. But I'm to run one.
I think it's time to bring Bolt and Spark together.
Also, finally, and with a I want to make sparks fly as a function of the decreasing distance between them. I'll use our unit conversion. Is in the Model 3D SwiftUI view now, and Bolt is an entity in the RealityKit greenhouse. You need to get the absolute distance between these two robots, even though they're in different space protocol. There's an absolute coordinate space. You can even to any coordinate space 3D, even from different RealityKit's entity and scene types conform to coordinate space 3D. Also, and SwiftUI coordinate space in Bolt's coordinate space, while taking model details like the mirror action into Model 3 view. When the view geometry changes, the system calls my onGeometryChange 3D function. It passes in a geometry property 3D, which I use to its coordinate space. Then I can convert my view's position to this function. Now, as I end up bringing Bolt and Spark together, coordinate directions.
creative way to upgrade your music slowly and like to free. Your ears deserve. Learn more.
Then I can convert my view's position to point and smell how far apart my two makes are. Brings both farther, the sparks increase. As shows them apart, next, I'll teach the robot to move together and to coordinate their actions. I'll use SwiftUI animation for allocated components. SwiftUI already comes with APIs to list and make changes to it. Here, I model view that spark is. I send over to the left and I toggle, and then bounce back to original position when I toggle again. I'm adding animation to my offset binding, and I'm specifying that I'm an extra bounce for. In Vision OS 26, you can now use animation to literally animate changes. All you need to do is set a support component on your thin animation, and the framework will take care of the rest. There are two ways to associate an animation with a stage. From within Reality, you can use set values for your components at the animate block. Reality Kit will be animation associated with the situation action that triggered the update closure, which in this animation, new left will be in a new position. The power of implicit animation I'm flexible the default release behavior for all manipulation by setting it to state. Then, grab the will release event manipulation instruction. And all the released by setting chance to edit scale, try to animate block. Sparky parts of original melody components, transform, and the models.
So reality working together.
Sometimes feel